Hey, welcome. You know that feeling when you're staring at a big, complex problem? All that data, all those equations, and you just think, where do I even begin? Well, if you've been there, you're in the right place. Today, we're going to pull back the curtain on a really powerful tool called MATLAB. And in just the next few minutes, I promise, we're going to go from a tricky physics problem to a crystal clear visual answer. So let's jump right in.
Okay, so our mission, if you will, starts with a classic physics challenge. We need to figure out the drag coefficient for a bungee jumper. Now, I know that equation might look a little intimidating, but don't get hung up on the symbols. All it's really doing is connecting a jumper's weight and their final speed to spit out one single, really important number. A number that tells us just how much air resistance they're up against.
But here's where it gets interesting. We're not just solving this for one jumper. No, we've got a whole crew of them. And as you can see, they each have a different mass and a different measured velocity. Now, can you imagine trying to crunch that equation for every single one of them by hand? It would take forever. There's got to be a better way, right? And of course there is. That better way is MATLAB. Just think of it as our own personal digital laboratory for this whole experiment. And hey, if you've never used it before, don't sweat it. I'm going to walk you through every single step, and you're going to see just how straightforward this can be. So what is this MATLAB thing anyway? Well, the best way to think about it is like a workshop. It's a space that's been designed from the ground up for people who work with numbers, scientists, engineers. It's got all the right tools, all perfectly organized to help us solve problems, analyze data, and create beautiful graphs, all in one spot.
And to really get a handle on it, let's start with the absolute basics. Because at its core, when you stripped everything else away, MATLAB is just a ridiculously powerful calculator. It's built to speak the language of math, plain and simple.
For instance, just look at the command window there. You can literally just type in a calculation like 19 minus 38 and hit enter. Bam! MATLAB just gives you the answer. There's no fancy code, nothing complicated. It's just you having a direct conversation with the numbers. It's a fantastic way to just get your feet wet. But okay, here's where things start to get really useful. Instead of just getting an answer and watching it disappear, we can actually store that answer for later. See that line a equals 4? That's called assignment. All we're doing is telling MATLAB, hey, remember the number 4, and from now on, let's just call it A. This super simple act of giving our data a nickname, well, that's the foundation of pretty much all programming. All right, so storing one number at a time is pretty handy, but our bungee problem has whole lists of data. So let's scale things up a bit. We're going to go from single numbers to seeing how MATLAB can handle entire data sets without even breaking a sweat. And the key idea we're going to use here is called a vector. Now, I know that might sound a little technical, but honestly, it's just a fancy word for a list of numbers. That's it. You know how you see a column of data in a spreadsheet? Well, a vector is just MATLAB's way of thinking about that exact same thing. So let's make this real. We're going to create a vector, and we'll call it M for mass. Then you see those square brackets? We just type out that whole list of jumper masses, separated by spaces. In one single line, all of our mass data is now organized and ready to go. And then we do the exact same thing for the velocities. We create another vector, we'll name this one VT, and we type in all those speeds. And just like that, our two columns of raw data are now neatly organized as variables right inside our digital lab.
Okay, our data is loaded, it's organized, now for the moment we've all been waiting for. This is where we get to unleash the real power of MATLAB, and you're about to see why this is such a game-changing tool for so many people.
So remember the goal, right? We have to solve that drag equation from the beginning, not just for one jumper, but for every single one of them in our data set. And we want to do it all in one go. And this, well, this is where the magic happens. Just look at that first line of code. We literally just type out the formula using the names of our vectors, M and VT. And because MATLAB is smart enough to know these are lists, it automatically does the calculation for every single element in those lists. What would have taken us ages to do by hand is done instantly. That one line of code is the absolute definition of working smarter, not harder. So we did it. We calculated all the drag coefficients. But right now, they're just another list of numbers on a screen. And to really understand the story that our data is trying to tell us, we have to see it. It's time to make a plot. And you won't believe how simple this is. We just use the plot command. We tell it what to put on the horizontal axis, in our case, the jumper masses, M, and what to put on the vertical axis, our brand new drag coefficients, CD. And boom, just like that, a plot appears. But a graph without labels is kind of like a map without any city names on it. It doesn't really tell you much. So the most important step is to add some context.
Using super simple commands like title, xlabel, and ylabel, we can clearly label everything. And this is how we turn a bunch of dots into a clear, compelling story that anybody can understand.
And hey, here's a quick pro tip to make your plots look extra sharp. You have total control over how they look. By just adding a few little codes, you can change the color to red, or you could swap out a solid line for individual circles. It's a super easy way to make your work look polished and professional.
And here it is, our final result. After all that work, this is our polished plot. And now we can clearly see the relationship we were looking for from the very beginning. As a jumper's mass goes up, their drag coefficient also tends to go up. That's a real insight, something that was totally hidden inside that original table of numbers. This right here, this is our aha moment.
So let's just take a breath for a second and look back at the journey we just took. We went all the way from a confusing problem to a genuine discovery.
I mean, think about what we just did in only a couple of minutes. We took on a real-world physics problem. We organized messy data into clean, usable vectors. We performed a whole batch of calculations with one single command. And we built a professional, insightful graph completely from scratch. That's pretty amazing. And this really gets to the core of why we do this stuff. As the source material says so well, the goal is to gain insight into the patterns and mechanisms hidden in the data. And that's exactly what we did. We found that hidden pattern that connects a jumper's mass to their air resistance.
And believe it or not, what we just did, we've only just scratched the surface. This fundamental workflow, getting data in, doing some math, and then visualizing the results, that's the foundation for almost every kind of data analysis you can imagine, whether you're in finance, biology, you name it.
So I want to leave you with this thought. Now that you've seen how simple it can be to turn a pile of raw numbers into a real story, what questions do you want to start asking? What patterns and stories are just waiting to be discovered in the data that you care about? Thanks so much for exploring with me today.